All right, well, this is a short video describing the titration of Tums, the experiment done for General Chemistry 2, wherein we have really kind of three parts. First of all, you'll take a Tums tablet. It weighs about 2 grams. You'll find the exact weight and put that in your lab notebook. You'll have it in an Erlenmeyer flask, and you'll add to it a solution that's known to have an exact molarity of HCl. So for example, I've used for this problem 0.750 molarity HCl. This will be provided for you in a hood. Because it's HCl, it's a strong acid. And you use a volumetric pipette. This little part here is where most of the solution will be, and there's a little line right at the top that you fill up this pipette all the way to that line, and you'll have exactly 25 mils. It's called a volumetric pipette. Well, anyway, you dispense of that into this Erlenmeyer flask that has the Tums, and pop, pop, fizz, fizz, so what a relief it is, you get this reaction. The calcium carbonate I've put in blue here. It's the active agent in Tums. It's reacting with an excess of HCl. I want to emphasize that. We have sort of two parts. The part that's going to react here shaded in, and then this dashed part is the excess HCl. That's going to remain even after the neutralization of the rest of the acid by calcium carbonate. And remember, it takes 2 equivalents of HCl to react with calcium carbonate to make carbonic acid. Now, carbonic acid, we know, is what we have as an acid in our carbonated drinks. So I'm drinking just water here. But if it was carbonated, it would have that tingle. But it doesn't. Why? Well, because we're going to let our Erlenmeyer, which has the Tums in it, sit in the presence of this excess acid until it's completely fizzed and it's done, and you've made carbonic acid. And carbonic acid, if you let a Coke out, it'll just go to water and CO2. You can see it here in the H2CO3. If you leave it out, this will just turn into water and CO2, and the CO2 as a gas keeps bubbling out, and so it drives the reaction to completion. All carbonic acid will go to water and CO2. Just like when you leave your Coke out, it goes completely flat. It goes to water and CO2. Now this is the key. This is going into the second part. We have excess HCl. The HCl, you might say, that's left over. That's now in this Erlenmeyer flask that had the Tums completely neutralized, and now we have an excess of the acid. So back into that same Erlenmeyer flask, we're going to drop. We're going to titrate a standard solution of NaOH. Now, I've just used an arbitrary 0.565 molarity NaOH for our discussion. In this case, you'll use your own standardized solution. And remember, this kind of gets us to the third part. At any point, usually in the beginning, you standardize your solution. It's your NaOH solution that you're going to use. You're going to standardize it. What that means is you're going to find exactly what the molarity is, because over a month or maybe more so a year, your molarity of a solution can change a little bit, and you want to be able to what we call standardize it. So how do we do that? Well, at the very, very beginning of this lab, you'll often take a solution that maybe was a 0.57, 0.56, whatever solution of molarity, and you'll check it. So you'll take that solution and you'll add it to a known weight. So you'll add it to a known weight of KHP, a known weight of KHP is the starting point. And you'll weigh that out into an Erlenmeyer flask. And for this purpose, we're going to make it blue. So we'll know exactly how much of that weight, and it doesn't really matter how much water you add to it, but some weight of KHP that you added to your Erlenmeyer flask, you just dissolve it in water, that weight, you're going to know the moles of it because you can divide the KHP weight by its molar mass, and you'll know the exact moles of KHP. Well, KHP and NaOH react in a one-to-one manner in an acid-base reaction, and I haven't shown the products here. I'm just sort of focusing in on these two react in a one-to-one ratio. Well, if that's true, then the moles of KHP is going to be equal to the moles of NaOH. And if I know how much I added of the NaOH to this known KHP in moles, if I know the volume, then I can divide the moles by the volume, and I'll have standardized to check that this solution is indeed let's say 0.565 molarity if it was just a year ago, or it might have changed a little bit. Again, this is called standardization of your NaOH solution, and it's usually done at some point in the lab before you can do your calculations. And we do it usually at the beginning, so I can know how much NaOH I transfer at any time with my standardized solution. All right, so let's say, again, we got that standardized, and we are back to our titration of the excess acid. We know that that excess acid reacts with the NaOH solution in a one-to-one manner. So if I know the amount that I titrate in, let's say it was 6.5 mils, and I know the molarity, again, having standardized that solution, then I can multiply the molarity times the volume, and I have to move the decimal place over. So 0.0065 would be the amount in liters times 0.565 would equal, and I'll just put it in standard, would equal, as far as the amount of titrated, it would be equal to 0.00367, we'll say. And if I don't know the HCl, now I do, because this amount of NaOH titrated into the titrand, the HCl that was excess, I know the exact amount of that HCl that we called our excess. It's also 0.00367 because they react in a one-to-one manner to make water and NaCl. So what I'm going to do is go ahead and stop there, because that gives you, I think, just a ballpark view of what we're doing in the Tums titration lab. One, we said we have a certain excess of HCl that we add, more than what we need. Why? To neutralize completely and quickly the Tums, or the calcium carbonate, in 2 grams of Tums. Once the solution is bubbled off, and it's come, usually after a half hour to an hour, it's reached a point where there's no more calcium carbonate. It's all converted to carbonic acid, and that again has gone to gas and just pure water, and we are left with our excess HCl. Then we take that excess HCl and titrate it with our standardized NaOH solution, which we had made using KHP. You always have to, again, standardize solutions that have set for a while, and we are going to do that for this lab. And we did. We can do that. We can take the KHP, again, known weight of it, know the moles of it, and if we know how much solution drips into that KHP to make it change from clear to pink, then we know the exact moles of NaOH. It's equal to the moles of KHP. And then we'll also know the volume brought down, and that'll give us our molarity, our standard molarity for that standardized NaOH solution. And once we did that titration, the second part with the standardized NaOH, we know the exact amount of HCl when we reach equivalence, when the solution goes pink. Thanks. Bye-bye.